Hi, my name is Mark Fleming, and today we're going to be talking about some of the theories of media literacy. This is a theory presentation for the ITEC 5320 class at the University of Wyoming in the spring 2018 semester. The purpose of this presentation is to act as an overview of some of the most important theories and scholars within the field of media literacy. This presentation should be seen as a summary and not as a complete or all-encompassing work. The theories will be organized chronologically from the oldest research to some of the most recent. As we progress through the presentation, you will be able to see how each work builds upon previous works to advance our overall understanding of media literacy. We are going to begin the presentation with the information processing theory developed and published by Richard Atkinson and Richard Schifrin in 1968. Information processing theory states that information is processed through human memory, which is comprised of a sensory register, short-term memory, and long-term memory. They are quoted as saying, "The theory is based on the idea that humans process the information they receive, rather than merely respond to stimuli." They also equate thought mechanisms to that of a computer. Just like a computer has RAM, or random access memory, as well as a hard drive, the brain has short-term as well as long-term memory. This can be best seen in the following diagram. One of the other interesting portions of this study was the idea of stage theory, or that information is processed in different stages. This multi-stage process means that information can be moved from the sensory register to short-term memory, or what's known as working memory, to long-term storage. When we need to remember something we've learned a while ago, we retrieve that from long-term and move it back to short-term for the time being. The next theory we will be discussing is one of my personal favorites, dual coding theory. This was discussed in 1971 by Alan Pivio. Dual coding theory states that the representation and processing of verbal and nonverbal information are conducted via two separate systems. The nonverbal system is responsible for information including what we see, hear, and smell, while the verbal system is responsible for information including words and text. One of the ideas of dual coding theory is that mental images created within our mind actually aid in learning, and that while these images are processed and stored in separate pieces of our brain, they can be recalled interchangeably. The word computer and an image of a computer can both be recalled either simultaneously or separately. Even though these two systems are separate, they come together in our working memory to integrate both into long-term memory. As designers, this is important as we can bolster learning through presenting information in two different modalities to utilize both systems. Next, we'll be discussing the model of working memory put forth by Alan Baddeley in 1974. The model of working memory proposed that short-term storage be known as working memory, and that it is run by what is called the primary central executive control. This acts as a supervisory system and controls the flow of information between three subsystems known as the episodic buffer, phonological loop, and visual spatial sketchpad. As you can see, each of these systems has a slightly different function, and this model works to clarify some of the tasks processed in information processing theory's short-term memory. We'll now be moving to the cognitive load theory developed by John Sweller in 1988. Cognitive load theory states that presented information imposes a load on working memory, and if working memory is overloaded, then learning ultimately suffers. The limited nature of working memory is compensated by the ability of long-term memory to store and organize information for future processing. Because there is a limit to the amount of resources in the brain, good design can use those resources in the most efficient manner possible, ultimately reducing cognitive load and decreasing bottlenecks that result in lost information. Cognitive load can be broken down into two categories: intrinsic cognitive load and extraneous cognitive load. Intrinsic cognitive load is, essentially, how difficult the content is. As an example, simple addition carries less cognitive load than abstract math and advanced calculus. Extraneous cognitive load is the difficulty of accessing the information by the student, or how that information is being presented. When these two types of cognitive load increase past the capacity of the learner, working memory becomes overloaded and information can be lost. Our next stop will be multimedia design principles set forth by M. J. Hanifin. Based on the previous research, Hanifin developed 20 multimedia design principles to work as guidelines on how to implement the research into multimedia literacy. I think this is some of the most important work, as giving designers concrete ways to implement theoretical information can be incredibly impactful. A few have been selected here as examples. Let's take a look at Principle 6 first. Principle 6 states that knowledge is best integrated when unfamiliar concepts can be related to familiar concepts. Because not all information will be familiar to the learner, designers should be conscious of this and provide conceptual links to previous content or to more well-known concepts. Also, because learners could be unfamiliar with the system interface, visual metaphors should be used to explain the learning system itself. Visual metaphors such as a computer desktop or a roadmap in the design interface can ease cognitive load as learners attempt to understand the learning system. Next, we'll take a look at Principle 7, which states that learning improves as the number of complementary stimuli used to represent learning content increases. This principle recalls the information from Paivio's dual coding theory. When pictures can accompany text or sound can accompany visuals, the learning of the content increases. Something for designers to be aware of, however, is that the pictures that accompany the text must be complementary. If the pictures are unrelated or only tangentially related to the text, learners could become confused and create erroneous connections. Principle 16 states that visual representations of lesson content and structure improve the learner's awareness of both the conceptual relationship and procedural requirements of a learning system. Providing roadmaps of lessons, or the overview visual that you see between theories in this particular presentation, can actually help learners become oriented with the lesson and ultimately oriented within the content. Principle 20, the final principle M.J. Hanifin posits, is that learning is facilitated when system features are functionally self-evident, logically organized, easily accessible, and readily deployed. Essentially, this is stating that if designers utilize best practice and make the learning system as easy to understand and user-friendly as possible, that learning will increase. If the user is struggling to get to the content because the learning system is in the way, they may become overloaded, confused, or frustrated, which could ultimately lead to them not understanding the content or quitting altogether. The final theory we will be discussing today is the cognitive theory of multimedia learning developed by Richard Mayer in 2003. Cognitive theory of multimedia learning is an expansion and clarification on all previous works. This ties the other theories together in one place while also providing suggestions and strategies similar to Hanifin that designers can implement as best practice. One of the things Mayer does in this study is to remind designers that multimedia just means multiple modalities, Words accompanying pictures does not have to be online, and that all mediums should use these best practices, from books to classroom web quests to huge learning management systems. He also reminded designers to be conscious of cognitive load theory and warned that overloading the learner with either intrinsic or extraneous cognitive load could result in loss of information. I think this graphic is a great summary of all of the theories we have discussed in this video. By showing that learning is a multi-stage process from the information processing theory, with multiple systems working together from the dual coding theory, as well as the multiple steps in working memory from the model of working memory, designers can efficiently utilize cognitive resources from the cognitive load theory. In conclusion, designers' choices have a significant impact on the information retained by the learner. Being intentional in every aspect of the design of a lesson is vital. Pictures that don't quite go with the content can hamper learning. Too much information in one place can hamper learning. No logical sequence can create confusion. Overloading a learner can result in loss of information. Designers must be careful to not overwhelm learners and to use best practices to most efficiently deliver information for maximum comprehension. Please also remember that these are not all of the theories, scholars, or principles that designers should be aware of when designing instruction. Design principles, educational pedagogy, and other instructional technology theories should be considered to best develop and implement instruction for an intended audience.